Okay, how's it going?
Pretty good.
Get back at it. So, October 8th. So my plans today are to review the ODP that you just finished, to talk about the next ODP, and all things related to those, and then just talk about some VI command usage. And that'll take us a class or two to do. So, questions? All right, well, let's start by looking at the ODP that you just did. So recall the purpose of this was to take an argument on the command line, print out its square root, but also do some error checking. And I listed three things to check, and these are listed in the order that you want to check them. So if there's not exactly one argument given, print out error. And it says use argc to check this. Let's just code that piece of it. We're going to run this program. Argosy will tell you how many arguments are on the command line. So if you run this with just the name ODP 409, argc will be equal to 1. If you say ODP 409 followed by anything, including possibly a number, argc will be 2. So if argc is not equal to 2, and we're supposed to print out ERR, and then just return. So make sure there's at least one argument given on the command line. I have a problem with my ends. So there's exactly one argument given on the command line. So that's what this check should do. All right, compiling again, quick reminder, when I compile, I don't want to just have my output file be called a.out. You can do that, but I'd rather have a separate output file for each program that I'm writing. So I use the dash output switch -o, which says the executable program should be called ODP 409. And then I list the program I actually want to compile, which is ODP 409.c. Okay, compiling is taking this, which is human readable code, and turning it into this, which is computer readable code. Right, so it's a translation process. We don't compile shell scripts. Shell scripts are human readable, but they are also machine readable. Okay, bash, which is the thing that's running our shell scripts, knows how to read the bash code that we write. It doesn't have to be compiled. But C code, we can't execute ODP 409.c, even if we make it executable. If we try to run it, it doesn't know what I mean by a parentheses or by integer main, right? It would only know how to do this if these were things that bash understood, like echo or variable equals variable. So C programs we compile to change it into this gobbledygook, this ones and zeros file that the system understands. So the output file was called ODP 409, right? That's this file here that was just created a few minutes ago. So I can run that ODP 409, and it says error. Why? Because I don't have a command line argument. If I say ODP 409 and I put an argument, it doesn't say error. If I give it 2 arguments, it says error. If I give it 3 arguments, it says error. If I give it an argument that's nonsense, it's okay, because I'm only checking is there an argument given. If I give it an argument which is empty, it's still okay. It's got an argument. That's all we're checking so far. Is there exactly one command line argument? Is argc equal to 2? So that first part of the program looks like it works great, right? It's doing this business of first bullet point, if there's not exactly one argument, print error and exit. Okay, there is exactly one argument. We're not done. We have to see if the argument is a valid double precision number. That's what sscanf does for us. So let's see if it's actually a valid double. Let me call it temp. So here's our variable we're going to use to hold it. Okay, so and remember, when we use sscanf, it'll try to convert our number, and it will tell us whether it succeeded or not. It tells us whether it succeeded by returning a value as the function value. So we need to save that return value. And what do we want to convert? We want to convert the first command line argument, right? Not the file name, but the first argument we put after that. So it's actually the second thing on the command line. That's argv bracket 1. There's the format we want to use. That's what we use for a double. And then we put the address of the variable that we want to save in. So that should try to convert, and if it succeeds, it will update the value of num, and it will return a 1. If it fails, it will not change the value of num, and it will return something different from a 1. Okay, so that's what sscanf is doing for us. Try to do a conversion. If it succeeds, save the value in num and return 1 because it's stored one thing. If it fails, will be unchanged and it'll return something different from 1. Okay, so if return value is not 1, it did not succeed in converting a double, which means the argument was not a valid double precision number, so we should print out invalid and exit. I got more comments than actual code. That's okay. Okay, so first piece made sure there was an argument. Second piece, make sure that the argument is a double. Okay, third step, argument exists, it's a valid number. Let's make sure it's not negative before we try to take the square root. The value of that number is in the variable num, because sscanf also saved the converted value for us. Okay, the number is negative. That's an error. Just print out neg and return 0. We're all set here. Print the square root. just exit. So we need math.h. And we need dash lm. And we need to declare num. Oh, I called it temp. Alright, so ODP 409, no arguments gives me an error. Too many arguments gives me an error. Exactly one argument that's not a number gives me invalid. Exactly one argument that's a number but is negative gives me negative. Everything's correct. Prints out the square root. And if you run it with no arguments, that's an error, not exactly one command line argument. If you run it with an empty argument, it's got an argument but it's not a valid double precision number. It's an empty string, that's invalid. So that should assess 10 out of 10. So if you do this in a different order, if you check the number of arguments down here, right? Give it a valid number, that works fine. Give it too many arguments, that works fine. Give it a negative argument, that works fine. Give it no arguments, you get a seg fault. Right? This was that famous second from the last test that people were having trouble getting points on. And what's the problem here? If there's no arguments, what's our code do? It takes argument 1, that's the second argument on the command line, and it tries to convert it to a double. There is no second argument. If you just type ODP 409 enter, argv bracket 0 is the file name, argv bracket 1 is null. And you're trying to convert null into a double precision number, that's the classic seg fault. The only way you can avoid that, other than checking to see if argv1 is null, is check the argument count. Right, this line down here actually tells you if I try to use argv1, I'm going to get a seg fault. So do that check first. Does that make sense? So I'll push that code over to, well, I'll push it now, but I gotta change it later. Alright, so that should be on the server. So that's kind of a prototype for how to use sscanf and how to deal with command line arguments in general. This will happen again and again. Anytime we're processing command line arguments, if we're doing error checking, we're almost always going to have to check argc to make sure we've got a valid number of arguments. And it may not always be if it's not equal to 2. Maybe you're allowed to have either 2 arguments or 3 arguments or no arguments. Right? So it could be a lot of different statements, but that's the idea of it. Yeah?
Also, about the third part, you check if the number is negative or not.
Mm-hmm.
So you use temp less than 0.
Mm-hmm.
You use argv1 less than 0.
So if I were to do this, right, like that. Right, so, wow, it shouldn't have compiled, but it compiled. Right, so I gave it negative 25. It didn't seem to notice that was less than 0. And I went ahead and tried to take the square root of a negative, and I got not a number. Let's print out argv bracket 1 as a double precision floating point number and see what its value is equal to. So if I give it the value negative 25, argv bracket 1 is equal to 0. And if I give it the value positive 25, argv bracket 1 is still equal to 0. So even though it compiles, which is a little surprising, argv bracket 1, if we treat it as a double precision floating point number, is not going to be the number that we want. Right? argv bracket 1 is a set of ASCII codes. It's an ASCII code for a 2, followed by an ASCII code for a 5, followed by a 0, the null terminator. And when we say argv bracket 1, what we actually get is, well, let me print this out as a hexadecimal number. Right? It's actually some weird hexadecimal number. It's a memory location. Because remember, argv bracket 1, even though we're saying bracket 1, is itself an array. argv is an array of arrays. So argv bracket 1 is an array. It's an array of characters. And when you use the name of an array, that's synonymous with the address of the first element in the array. So this is a location in memory where this string 25 is being stored. And if I run it again, I get a different value because it's stored at a different location in memory. So the whole purpose of sscanf is to take this collection of characters and change it into a different format. So it's no longer an array of characters, now it's a double or it's an int or something like that. Right? So that's what sscanf is doing, is taking this thing which doesn't work and putting it in the form where it will work. Does that make sense? Okay. All right. Any other questions on scanf, and so on? We'll keep hitting this repeatedly. All right, so let's look at the current ODP. So current ODP is doing the following. And this is going to be a C assignment, but now we're going to start writing functions instead of main programs. This is going to take away all the weirdness about formatting the output and so on. Your goal here is to write a function in C called pick. And the prototype of a function is just what's the name of the function, what type of arguments does it expect, what type of argument does it return. So this is a prototype for pick. It takes an integer argument and it returns an integer value. And it does the following. If you pass it a number n, it should calculate n mod 4. And if that's not equal to 0, that's what it should return, n mod 4. If n mod 4 is equal to 0, in other words, if n is a multiple of 4, then pick should return 1. So this is a function that tells you if there's n sticks left in the pile, how many sticks should the computer take. And in general, it'll be the remainder of n divided by 4, unless that's equal to 0, and then it'll say take 1 stick. Right, so again, part of your part of your PA2. Okay, so assessing these is a little different. But everything you need to know is spelled out in here if you follow it all, okay? So first thing you want to do, you want to write your function, put it in a file called pic.c. Don't put a main program in. You're not writing a main program, you're writing a single function. Okay, so pic.c. Okay, so let's write a pic.c. I don't need to include stdio because I'm not doing any output or input. I can include it, it won't do any harm, but it's totally optional. Okay, so our function should be called pic, takes an integer, returns an integer. So integer pic, and it's just going to take some argument. And I don't know how to write pic because I didn't read the instructions, so I'm just going to return the number 2 regardless. Okay, my goal here is just to show you how to get this into the assessment system to get a grade on it. But your program shouldn't just return 2, it should return some argument mod 4, unless that's 0, and then return 1. Okay, so here's my pic code. All right, compile it saying gcc-c pic.c. That lets you check your syntax. It does not give you an executable program. There's no main program in here, so I can't run this. If I try to actually turn it into an executable program like pic, I'll get this weird message saying there's no main, undefined reference to main. Okay, that's good. You don't want to put a main program in here. So it's just a function. Okay, but you want to test this. You want to write a main program yourself, right? So here's what you might do. Let's make a main.c. So when you're going to use a function, you have to put in a prototype for it. You have to tell the compiler, I'm going to use a function called pic. It's going to take an integer, return an integer. So I want to test my code. I'm just going to call my pic function with different values. And in each case, I'm going to save the result in something called result. And I'm going to print it out each time. So here's my test program. And I expect that it should print out a 1 and a 1 and a 3 and a 2 and a 1. Thank you. All right. Yeah, put your return at the end. All right, so this is test code. Okay, so to test your main program, you can say gcc-o main, main.c, pic.c. This is assuming your main program is called main.c. And I run this, well, every time I called pic, it gave me a value of 2. But I have faith that that's probably pretty right anyway, so I'm just going to go ahead and assess, because I don't want to actually show you the code for pic. Okay, so let's say that I'm confident that I've run my test program and this is working fine. Actually, let me show you a better test program. So let's just make a little loop. We'll run I from 10 to 20. We'll call pick of I, save it in result, and then we'll print out pick parentheses I equals the result of calling pick. So we'll test pick on all values between 10 and 19. Right? This is a pretty extensive test. So let's recompile that and let's run it. And well, okay, my pick function's not doing too great. But let's go ahead and assess it anyway. Okay, once you're convinced that it works, assess it as follows. So compile using this statement. gcc-o pick.c and then /temp/odp410 main.o. Okay, this is what we call a test bed. This is your main program. Okay, pick.c again is just one function, pick. When you're testing it yourself, you make your own test bed. That's what main.c was. It's something that exercises the pick function. When you want to assess, you link pick.c with my test bed, which is /temp odp410 main.o. This will give you a new executable program. Called pick. Don't run pick. I have no idea what pick will do. It's just kind of sitting there. And who knows what it's doing. It's doing stuff that's deliberately not clear. But pick is what you're going to use to assess. So the assess command, assess, executable program, and then your source file. So assess pick pick.c. And go ahead and grade that. And I got a 0, not surprisingly. Okay, so here's a version of pick that is good. So let's put that in with my test bed. And let's run main. And that looks like the right performance, right? 10 and 11, the remainder when you divide by 4 is 2 and 3. That's what pick returned. 12 has a remainder of 0. Pick returned 1. That's good. 13 has a remainder of 1. It returned 1 also, right? So this looks like it's going to work well for me. Let's go ahead and assess it. So compile pick.c with the test bed, call the output file pick, assess that output file, the executable pick, followed by my source code, grade that. There's your 10 out of 10. So all of that is in here, right? But if you don't read this and follow it religiously, you're going to be one of the people who's up at 10 o'clock tonight saying, I'm getting this weird error from assess, or I'm running pick and I don't know what it's doing, or things like that, right? If you put a main program in pick, you'll get errors when you try to do this compilation. Because this test bed has a main program in it. If pick.c has a main in it, you're going to have 2 copies of the function called main. Compiler's going to be unhappy about that. So even if you're not 100% crystal clear on what each of these things do, if you follow these things, you should be able to assess your code. But if you're not clear on what these things are doing, we can definitely talk about it, right? And you're going to be doing this for most of the remaining ODPs in this course, is writing a function, linking it in with a test bed. Okay, certainly all of this week's ODPs are set up like that, starting today. So questions about that? And it's another one of these things that's going to be a whole lot clearer when you actually do it than when you listen to me talking about it. Right? It's really only a few commands to do, and just keep coming back and referring to this when you have to do one of these. All right, let's see. Let's talk about VI. So VI, we use it in 121, and it's set up so that you can basically move around with your arrow keys, right? You can backspace to get rid of things. you can type to put things in. And most people, when they run VI, they start off in what we call insert mode, which is the mode where whatever you type goes into your file, unless it's a backspace and that deletes, or an arrow key that moves you around. That works, but it's really kind of like using Notepad, right? Where you open up a window and you move around and you can type. It's not terribly efficient, particularly if you want to get rid of a section of 5 lines of code. Most people will just hold down the backspace key and delete the 5 lines, and hopefully not delete too much, or they type it back in and so on. So the first thing to know is that there's 2 modes. There's insert mode and there's command mode. And most people are used to living in insert mode. I'm going to suggest you really want to live in command mode, because there's all kinds of commands you can use in VI, but you can't use them in insert mode. If you're in insert mode and you type DD, it inserts DD into your file, right? If you're in command mode and you type DD, it deletes an entire line, which can be useful, right? So mostly we're going to live in command mode. If you're in insert mode, how do you get here? Hit the escape button. So escape is the button that programmers use sometimes when they're stuck, or they're bored, or they're thinking about something, or they just want to, fidget, but there were no fidget spinners around. Just hit the escape key, right? Because it doesn't do any harm, because you're in command mode anyway. If you have sound turned on, it'll beep at you sometimes, or flash your screen. But if you have that off, escape is just kind of a harmless, nervous thing to do. So let me see if I can find a good file to mess with. Probably not. Why is my stick only 11 lines? Oh yeah. Okay. So before I do this, I'm making a copy of my file called stick.save, because I'm going to do all kinds of weird edits on here. But let's edit this. I need to run through this code. Maybe not. I think everybody nailed this enough. All right, so VI stick, right? I've got 152 lines, 2,900 characters in here. And I'm in command mode. Okay, you start off in command mode. So first thing is moving around, and HJKL lets you move around. H goes back, J goes down, K goes up, L goes to the right. And they're like arrow keys, but believe it or not, when I started programming, there were no arrow keys on keyboards. They were typewriters, right? So J goes down, and L goes to the right, and H goes back, and K goes up. And if I happen to be over here and I say J, it knows where I am, right? If the line's not long enough to be in that column, it takes me to the end of the line, but when I go to the next line, I'm back in that column. And that can be useful. And the same with K for going up. Okay, we can also use a space. And space is the same thing as moving over one spot. So H goes back, space goes forward. That's the first way to move back and forth on a line of code. J and K are used basically to get to a line, and then H goes back, space goes forward. All right, spacing is a pain. You can wait for auto repeat to kick in, but it's not very precise. So if you want to move into larger chunks, you can use B to go back a word. You can use W to go forward a word. So if I hit B, it goes back to a word at a time. And what is a word? I don't actually know, but it's stuff that's separated by other stuff. So certainly you have a bunch of words separated by spaces, those are words, but some punctuation also counts as a word. So let me just hit W. I'm at echo. If I hit W, it takes me to the double quote. If I hit W again, it takes me to the start of must. Be a valid integer. If I hit W again, it takes me to the punctuation, and then to the at least 10 and the quote. If I hit W again, it breaks me to the next word, even though it's on a separate line. So if I just lean on W, right, I'm moving forward, but a lot faster than if I just lean on the space, and the space stops at the end of the line. So that's a faster way to move around on a line, and B is exactly the same, but it moves backwards. There's also a shortcut. If I want to get to the beginning of the line, I can just hit a 0. I can also hit a caret, but everybody I know uses a 0. 0 actually takes you to the very beginning of the line. Caret will take you to the first non-space on a line. But if I want that, I just hit a 0 and a W. So 0 is the beginning of the line. $sign takes you to the end of the line. Right, so these are useful if you want to change something at the end, right, instead of going over one character at a time, right, or even going over one word at a time. Just hit a $sign and bang, you're right at the end. When you get to the beginning, hit a 0. All right, moving up and down. J will move you down, K will move you up. If you want to move down more than that, Control D moves you down half a page. Control U moves you up half a page. So hold Control D, you can quickly get to the bottom of the file. Control U gets you up to the top. All right, so a couple of disclaimers here. First of all, there's a quick reference guide I posted on Canvas. This was just a card that I found online and I ripped. And it's got, I mean, I gave a quick look over and it seems to have the basic stuff. But there are millions of these things out there, right? And so the usual disclaimer is that there's a bunch of stuff in VI, right? There's whole books written about VI. It's a whole sort of environment you can live in. And this is a really small subset. But this is the subset of things in VI that I tend to use on a daily basis. And that doesn't make them good or bad. It's just the ones that I've sort of settled in on. For example, I never use caret to go to the beginning of a line. I use 0. But take a look at, you know, this or some other quick reference, compare it to what we've gone over in class, and, you know, sort of develop your own subset of preferred commands. You don't need to learn 100 different commands in VI to be efficient at it. You need maybe, you know, 15 or 20. But they got to be the 15 or 20 that kind of resonate with you. Right? If you take my list of commands and you try to force yourself to use those, it may not work very well. So you want to sort of figure out what makes sense for you inside VI. I'm giving you some things to work with initially, maybe. But, you know, look at some references, do some stuff online, and try different things. It's a personal choice. All right, so most of these commands will let you put a number in front. So H moves back. If I say 5H, that's like hitting H 5 times. So I'm sitting at the end of the line right here. If I want to go back 5 characters, I can say 5H, and it brings me back. If I want to go back 5 words, I can say 5W. If I want to go down 4 lines, I can say 4J, and it brings me down as if I said J 4 times. And that's a general thing. Most of these commands, if it makes sense, you can put a number in front, and it'll do that command that many times. All right, searching. Your main way that you start a search is a slash. Again, all of this is only in command mode. If you're in insert mode and you say slash, it inserts a slash. Command mode, if I say slash, it brings me down to the bottom of my page and it shows me a slash. And I can say, let's search for the word stick. So I'll just type in stick and hit enter, and there's where it finds the word stick. It's actually sticks. I just asked it for something S-T-I-C-K. If you want to repeat that search, you don't have to say /stick, just hit the letter N. That says show me the next occurrence of stick. Hit N again, there's the next occurrence, and so on. So that's a really fast way to sort of move through your file. If I want to search in the opposite direction for my last thing that I searched for, I can hit a Shift N. So that'll move up in the file and find an occurrence of the word stick. And if you go too far, it'll say search at the top, continued at the bottom. Or if I'm searching down with an N, it'll say search at the bottom, continuing at the top. It wraps around. So that's a slash. If you use a question mark, that says search going in the up direction. So if I'm down here and I say question mark stick, it'll search for an occurrence of stick previous in the file. And an N will search for the one before that, and so on. And in that case, a big N will search in the opposite direction, which is going down. Okay, gross movement. If you want to move to a particular line, you can say something like some number followed by an uppercase G. That means go. So in particular, if I want to get to the first line of the file, I can just hit 1 followed by an uppercase G. Takes me to the first line. If I want to get to line 100, I can say 100G. Takes me to line 100. And I can hit a Control G to see where I am. Control G, it says line 100 of 152, 65% of the file, and I'm in column 5. So that's Control G. If you want to get to the end of the file, you could do this and say 152 uppercase G, but that's a pain. So if you just say uppercase G without a line number, that takes you to the end of the file. Okay, so that's moving around the file. How about adding things to the file? So how do people insert? Do you use I usually? Okay, so if I say I, that says insert right before my current position. So I type in I, and I can say this is new text, and it inserts it right before there. As soon as I'm done inserting, I'm going to hit an escape. So I'm back in command mode. By the way, there's an undo. If I hit U, it just undoes what I just did. If I hit it again, it undoes what I just did, which was a U command, so it undoes the undo. So it's a redo. That changes from installation to installation. But one U should always undo the last thing. Okay, suppose that, I forgot to put my exclamation mark in here, and I want to add an exclamation mark after the number sign. So you got a couple of options. You can move over and then say I to insert right before that. But you can also say A. A says append. So A will insert after the cursor position. I inserts before. So if I say A and I type an exclamation mark, it goes right after where I was. That's not a huge deal. It's not that hard to just move over and say I. Unless maybe you want to add something to the end of a line. Because if I say I, it's going to insert right before that H. So how do I add something to the end of that? Just type in A and starts adding at that point. Okay, so I and A start inserting. If you want to insert a new line below this one, type in O. So O means open a new line. Type in O, creates a new line, put your cursor there, and you're in insert mode. If you want to insert before the current line, type a big O. So if I want to insert something right before this, I can just hit Shift O, and this comes first. All right. Change word. So suppose I want to change this word must. CW will change everything up to the next space or punctuation. So CW it shows me a $sign for the end of the word, which means I'm changing everything between my current position and that $sign. And it can be shorter, it can be long. It's basically just going to substitute that one word with whatever you type. Little r is to replace a single character. So if I wanted this to be an E for some reason, I could just say R and type a new character and it'll replace that. A Shift R is like putting your terminal into overwrite mode. It lets you type and it overwrites whatever is there. So if I say Shift R, it's just overwriting what's already written there. It's not moving it over, and sometimes that's a good thing to do, sometimes it's confusing. At any point you can hit a period and that says repeat my last command. So if I want to replace that, if I want to repeat that replace statement right here, I can just hit a period and it redoes that. If I want to add a comment here, so I did an O and I typed this in, and maybe I want to do that everywhere that I want to comment, I just come down to this spot, hit a period, and it repeats whatever that instruction was, which was open a new line, add this piece of text. So now I can comment my code really efficiently, right? Just go everywhere that I think I want to comment, and you know, I can add a comment on every line if I want. Okay, so that can save you a lot of typing. We're like a third of the way through my list of like. All right, so I want to talk about removing text. Okay, ways to delete, including the fact that you can just do a DD, and that'll delete a line. And if you want to repeat that, you can just hit period, and that'll keep deleting lines. Or if you want to delete 10 lines, you could say 10DD. All right, so I want to talk about ways to remove text, either characters, words, or entire lines. I'm talking about copy and paste, changing case, joining lines, and then I want to talk about some of the things you can do with this colon besides just save your file and exit. There's all sorts of things you can do here. So we'll keep going on this tomorrow. All right, I'll see you then.